Hey, hey. Um, so I am Sandra. I'm looking after our community at Cohere. Um, and I am here today to share with you, or to sort of facilitate the sharing with you of one and only Jay Alammar's one of the many awesome creations he has done so far with Cohere platform. Essentially, what happened was Jay created a Hacker News uh, map of Hacker News posts of all time using the embed endpoint. And so today he is kind enough to show us around and answer any questions about it. So just a heads up, during our meeting today, there will be time for the demo and time for the questions. So please wait with your Q&A until the end of Jay's lovely demo. And yeah, Jay, thank you so much for joining us today. Show us what you have built. Tell us how it happened and so forth. Over to you.
Absolutely, will do. Thank you so much, Sandra. Great to be speaking with everybody here. Yeah, this is the culmination of a few different projects, and I'll start by sharing my screen. And first, so you can, let's see everything that I can show you. So are you able to see my screen?
Yes.
Oh.
Yes.
So you can follow along to this by going to the Cohere notebooks. I'll be talking about a few of these notebooks. So the first one is Semantic Search. So one of the most powerful ways to use large language models, and specifically embedding or sentence or text embedding models, is to use them to empower search. So Google Search uses this, Bing Search uses this. It's a very powerful capability. And in here, in this notebook, we created, let's say, a quick guide to show how that is done. So you have an archive, you get the embeddings of the text in your archive, and then whenever you get a query, you embed that, and then you just compare, you just do a similarity search, and that gives you really good results that are better than keyword search in certain ways, in that it enables you to search by meaning, not just comparing words. And in this notebook, we get this data set of questions, and then we find sort of the most similar questions, kind of like, similar questions feature of Stack Overflow. This goes over how we embed the archive, and then just how to do the entire search there. At the end of this search, we did this. So maybe sometimes you want to explore your archive, not just by searching, but you want a visual of how to look at it. And this is one way to plot embeddings. So if you have a large number of embeddings, you can plot them kind of like this. And this is an interactive one where if you hover, you get to see sort of each point is a sentence and what it is. And clusters in the text are sentences or pieces of text that are similar.
Essentially, us telling you that.
Guys, mute yourselves once you joined so that we don't interrupt the presentation. Thank you.
Appreciate it. Yeah, so this is like a type of visual that we showed in the Semantic Search notebook. So there's one issue of this, which is, when you have hundreds or thousands of examples, you don't want to touch or hover over each point to really get a sense of what the message is or what the piece of text is. And this is a use case we've seen a lot with people who are interested in language models, prospects and customers who want to explore. Let's say they have a large database of customer emails or tweets or messages, and they want to see, what are the themes that are commonly recurring? And so this kind of visualization and exploring the clusters is a way that gets a lot of information out of vast amounts of text. And so this is what this Hacker News post does. And Hacker News basically is this website where people vote on articles, kind of like Reddit. It specializes in technology and startups, and people vote on the things that they like, and then we use that just as one data set to explore, because I've been using the forum for a long time, and there are some really interesting discussions in some of them, so I wanted a better way to find really good discussions on the forum. So that's what this post on the Cohere blog sort of goes after. It begins with showing some of the interesting areas of the site that we found, and each one of these, for example, is a web page that will show you articles or discussions of a specific nature. And then the rest of the article has, there's this visualization that you can explore for yourself. So this is for 10,000 posts. And then there's another one for the top 3,000, which is for one section of the site called Ask Hacker News, where I found sort of the most relevant or most interesting. And how this figure is different from this one, as you can see, is that this one is broken down into clusters. So we have 8 different clusters here, and you can browse them individually and gain insight into what are common themes that occur in messages or in titles that are similar to each other. We describe the whole sort of process here. We provide the embeddings and the CSV. So this is a good sort of first project if you want to explore this. And this is an exercise in a task called topic modeling. So this is something that NLP has been used for a long time to sort of carry this out. And it's a common need in business and in research as well to be able to cluster and to group and find, let's say, topics in a lot of articles. But here we do it with large language models and with embeddings, text embeddings, while previous ways really relied on words that appear together, which capture some of the meaning, but not all of it. So embeddings are better in involving the context and sorting things by meaning, which with words you don't always get the best results on those topics. So here, just scrolling through 2,000 headlines, it's very hard for humans to parse this. So a visual is a good way to really look at that. So here we get the data set. The data set is listed in BigQuery as an open data set. So we query it for all the articles with more than 10 votes or upvotes. And then we embed it. So we get the pieces of text, we throw it at the embedding model or representation model, and we get this 10,000 by 1,000 matrix, where it's 10,000 article, and each article has an embedding vector of, say, 1,000. That's what the embedding call looks like. So here, this would be the 10,000 headlines. We throw it at the model retrieves those embeddings, and then we can do interesting things with them. One of the first things is what we showed there is to plot them. So we do the step of dimensionality reduction. It's a method called UMAP that would take this embedding of 1,000 vectors, 1,000 floats or numbers representing each sentence, and project it down to 2 that we can plot, so an X and a Y. And then that's how we end up with a shape kind of like this to explore. Here we show some examples of keywords that we can search for. So we can see, let's say that here at the top left, there's a lot of databases, but also, Postgres is here. So databases are all clustered in one place. And this shows a few other examples. Then to move from a shape like this, where they all have the same color, to a shape like this, where they're clustered or grouped, we do the following. So we just run a clustering algorithm called k-means that we get from an open source library called scikit-learn. We run that on the embeddings, and then we use that to color the points. So we didn't change where the points are. We still use the UMAP version. So the points did not move, but the colors that they have changed a little bit. And then using this other method called CTF-IDF, we can assign each cluster keywords that are relevant to that specific cluster. Because if we don't do that, we have this. So each cluster just has a number, and we don't really know. Okay, so these are blue points, these are pink points. What do these stand for? Well, if we apply this keyword extraction step, we can see that, okay, the green one is about reading books, people, potentially recommending books and blogs. This one is one of my favorite sort of clusters, and it's probably the reason why I did this entire exercise, is these things where people ask for or share life advice and sort of either technical or personal. So these keywords sort of are able to give us some sense of what lies behind each cluster, and that's useful with 8 clusters. But it's also even more useful if you break things into a lot more clusters as well. After clustering, we can also do like figures like this to see which clusters are more similar and sort of how the hierarchy of groups in the text are like. And that's how we do this graph. This is where the post stopped. One step that we sort of wanted to do here, and we continued a little bit in the forum, is to say, okay, so here, so this is, okay, so you see where it says keywords? So these are the keywords for this pink cluster. Self, CS, courses, design. So here we're listing the top 10 keywords. But then we really wanted a better title for this. The keywords are sometimes useful, but could we break it down into 1 or 2 or 3 words, or like maybe a short sentence that is able to be a better name or title for this cluster? So one thing that we tried is to say, okay, maybe we can generate that name through a generative model that we give the keywords to, and we have it select sort of the name. So this is what kind of a generative prompt is. So we give it 3 examples, and we name them, and then here we insert whatever cluster that we want, and the model is supposed to generate what it is. And there was a good discussion here, and good, I think, feedback from a few people who wrote in. So one thing that we got out of this is, we're able to improve by enabling the model to use cluster keywords of more than 1 word. So you can have 2 or 3 words in a keyword, and that improved the quality a little bit. And then sort of the final thing that we haven't really deployed or developed yet is something I've been sort of working on, which is this kind of an interactive demo that you can use on this dataset or other datasets. So once you have the embeddings, I developed a version of this while in a notebook form while developing the article. But it looks kind of like this. So I wanted to have an interactive way to set the number of clusters. So we start out with 1 cluster, but let's say we break it down to 8. And so here the model goes in the background and breaks it down into the 8 clusters, and we have our interactive visual. And this, we can change this to any number, and this will happen right away. So we can zoom in on various clusters and get a little bit more detailed and specific in the clusters that we look at. A next step here is to say, okay, so these are the keywords that we got. Let's do an exercise of labeling these clusters. And so one way is this prompt that we showed earlier, but I wanted to improve a little bit on it. So I've been working on a new prompt that generates a title not just using the keywords, but also looking at a number of articles from the cluster. And so this is still sort of work in progress. So let's see, maybe we can have, if we have a larger number of clusters, we can have a little bit more specific. So here, things about learning, some math, some design. When we click this, we can get some suggestions from the model that would look at the keywords, would look at the articles, and give us a suggestion. This is one way to demonstrate how when we use the generated models, we generally want multiple generations. So we don't want the model to give us just one output. We can usually get better results if we generate multiple results and we choose some of them, or the better ones. And so here we're generating 3, and this is a variable like we can change. And if we don't like any of them, we can click again and have the model generate a few more. And so this is using the X-large model. And the prompt for this, and we have a button like this for, let's say, each one of these. So, I mean, I'm still sort of thinking through a good flow for this. So maybe we can have just one button that generates the thing for all of them. You see, this one is reoccurring. I think that's because it's in the prompt. So this still needs to be tuned a little bit, but this is potentially a better use or name. There's YubiKey here, so it's kind of like authentication. Maybe not. So this is, we're work in progress now. And I think this is a good point to stop this and take any questions we might have and just discuss topic modeling in general, using these models for it, or any experiments anybody here has had with those kinds of use cases.
Awesome. Thank you so much, Jay. That was great. I've posted some links to your article and also to the map and to the Collab notebook you've been mentioning. So guys, check it out in the chat. Do we have any questions? Shoot. I have some questions, but let's hear from the guys that showed up.
Hello, Jay.
Hello.
Thanks for the session. My name is Bala. So before I ask the question, I just want to say I'm a big fan of you. I'm from India. I follow a lot of NLP tutorials from your page. You know what? I know what is attention is all you need just because of you.
Awesome. That's great to hear. You're so kind. Thank you.
I just have one question. I just want to talk about my approach in topic modeling, and also I have a question for you. What I felt is like having a topic modeling instead for the multiple documents, trying to get the topics in one document made more sense for me, because in one single document you may have multiple paragraphs and each paragraph talk something different. So the use case what I'm trying to solve is like extracting the major themes from one document. And that is what I'm doing, and I am so much curious to know about generating the titles. Like once you get the subtopics for each and every single paragraph. So what is that? Like I'm hearing it for the first time. Is it something new from Cohere, or it's an existing model?
Yeah. So there are a few different ways to tackle this. So CTF IDF is part of. It builds on the TF-IDF algorithm, which is sort of well known, but it just applies it not to documents, but to the clusters. And it's part of the open source library called Bird Topic. So that's the one that extracts keywords. And then you can change that by changing it uses a count vectorizer from scikit-learn that counts the number of words and how much they reoccur in each document or each cluster, and that's how it sort of gets the most the words that are most relevant for this topic that appear a lot in this topic, but not a lot in the other topics. And so that's one step. The second step that we're sort of on the forefront of is how can we do this with the generative model? How can we have the generative model, because they seem to be quite capable of doing this once we sort of identified the right structure of the prompt and what kind of information. So we did that by the two examples we showed is one by giving it the keywords and having it generate a title, and then the keywords and some examples. So we're experimenting with giving it 10 articles or 10 titles to be able to name them. So yeah, these are the two steps of the approach and sort of their sources, I guess.
Okay. Glad to know those. I'll keep in touch with you and get more understanding from the modeling. Thanks for the
Wonderful.
response. Thank you.
Thanks a lot for the question. So do we have another one? Meanwhile, Jay, I have a question, which might be silly, but this was something on my mind while listening to your presentation. How does one come up with an idea of building a Hacker News map? Like, what led you there? What sort of thought process made you think this would be like an interesting chunk to bite on? Like, I'm always curious about the process of arriving at this use case for large language models.
Yeah, so it's two things. So one, it's the looking at that figure from Semantic Search and just looking at a map of 5,000 points and thinking there's got to be a better way to really get more information out of that plot and to impose a lot more information by looking at that graph. So like the first point there is just that desire to do a better job with visualization, with data visualization, which is how can we better optimize the visual or the plot to communicate more information about the underlying, because the embeddings capture so much information about the topics, and just using it just to identify sort of the plot, the point where to plot, it seems like only the beginning of where to do that. So that first problem, this was the first problem, and then after this was like, okay, how do we demonstrate this better method? So for me, I was looking for what are interesting open data sets that has a lot of points that I personally find sort of interesting, and Reddit was one place, and there is an open source Reddit in BigQuery as well, but it's much older, while the Hacker News one is a lot more recent. And so it comes from these two things. And so like deep interest in these topics and the discussions. There are some very valuable discussions that you can only find if somebody links them to you or if you search by keywords. There's no way to really explore and say, okay, I kind of like this topic. How can I explore other articles like it? So these 2 points, I think, together, bring this idea.
Awesome, thank you.
I have a question, if I can ask. So I was just wondering, like, if we were to add a new article that we found on Hacker News and then want to like map that into the current like the embedding, like, would we have to run the model again with that article as a part of the data set, or is there like other more cheaper way to have that?
So you just need to embed that article, get that embedding, and then you pass that embedding by the UMAP function that we created in the beginning. So it does not need to be trained again. But if you train the first UMAP on 5,000 articles and then you want a new data set with 15,000, maybe that's a good point to retrain the UMAP sort of transformation. But if you're just adding a couple more or a small number, you probably do not need to retrain the dimensionality reduction sort of transformation.
Correct. But to fit this article, the new data point, I would still need to get the embedding through the language model. Is that correct?
Yes, the embedding of that one article, exactly. Or
Right.
title. We're doing titles here.
So I'm just wondering about the scalability. So if I were to have like a Google Chrome extension where I'm just browsing through Hacker News, and then there's like 100 posts that I see throughout the session, would it make sense to like get the embedding of each article that I see, or is there a way to kind of memoize or like train like using the embeddings that's already there to like kind of do it locally? I'm just wondering if there's a way to do that.
Yeah, well, so I guess depends on how much you want to embed. I guess how much text you want to embed and how important the problem is. So I limited it specifically to 10,000 and then zoomed on 3,000 specifically using the score. So I chose the top scoring ones. That was my way of sort of limiting the amount of compute, but also limiting the amount of attention. So, there's these Pareto rules where, a lot of the more interesting things happen in the top, let's say 20%. And so, these are all sort of design parameters of the problem that you want to tackle.
Yeah, thanks. I appreciate it.
Yeah, amazing.
Thank you for the question. Actually, I see that. Oh yeah,
One question.
go ahead. Yeah, go for it.
Yes, about the how to check the relation between the title and the content of the article. Most of the time, the title of the outline of the article, it's more so sophisticated and doesn't reflect the content of the article. And this is most shown in many articles, that the title speaks about something, but the content you discover after reading it's totally not, they are not related to each other. How to make this compromise without losing the accuracy in your model?
True. Yeah, no, that's a good point. So, these are two, let's say, caveats of this approach. It's a general sort of demo to demonstrate the idea. So one, it uses titles, but also it uses longer titles. So, titles that are short, 2 or 3 words, don't have enough sort of information in their embeddings to really be plotted well. But you can embed the articles just as well. So the embedding model can take maybe up to 2 pages of text and turn it into a vector. So in those use cases, it's a lot better to just throw the entire article or email or the first, let's say, 2 pages of it if it's longer form than 2 pages and get that.
Thank you.
Thanks.
I see that Jeremy had a question that he posted on chat. Jeremy, do you want to follow up on this, or did the rest of the presentation answer it?
Yeah, I had asked that question right before the answer came up. I was just curious if there was a way to just like share the intuition about how many clusters were the most effective, or how you went about arriving at the conclusion there. I see that there was a little demo tool that was used and very helpful to kind of empirically just like scale up and get that visual feedback of how clusters would emerge. I guess the major question I was thinking about are the edges of the clusters. Like, do you find that the posts there are very ambiguous, and that's why they could they look very close to each other? The patterns that come up here are very, I would not have guessed them. There's like a smattering of colors sometimes on top of each other, but maybe that's just something like an offshoot of the dimension reductionality, and I'm missing a dimension visually. But I think the tool that you showed off there helped to guide me towards the intuition.
Awesome. Yeah. So a couple of things we can sort of point out here. Let me share my screen again. So let's say the steps that we're doing here is, okay, so one is the plotting of UMAP, and then the other one is the clustering. This is not the only way to do it. There's another way to do it, which is by clustering the graph itself. So you can run the same clustering method, not necessarily on the embeddings, but you can run it on this XY. And in that case, that would give you clusters that are, not overlapping in the graph, in the plot. But then one thing that you're losing here is that you're doing the clustering on highly compressed data. So the piece of text or the article is no longer represented by 1,000 figures. It's represented by 2. So my intuition here for this choice is to give the clustering method the representation with the most amount of information about the text. Now that does lead to this overlap between and there are 3 approaches. So this is one. Another one is to do the XY, but that also feels very compressed. There is a step or a way in the middle to say, okay, so these embeddings are in 1,000 dimensions. Let's reduce this from 1,000 to 10. And then those 10 we cluster, and then we do UMAP on those 10. And so we have some amount of compression on the embeddings. And that compressed version we use to plot and cluster, and that would lead to less overlap. And this is more of the approach that per topic does. And so, these are 3 ways to kind of go about this. Now, to explore, the number of clusters, it really depends on the amount of text or data points that you have. I found that when I set something to a very large number of clusters, I couldn't identify the general picture. So, I would get a lot more details about specific areas of clusters. And some clusters, let's say 5 or 10 of these clusters would be very specific about topics. And that's what's interesting when you do a large number of topics. But then once you do, let's say, smaller number of topics, you get an idea of a higher level sort of breakdown of them. So you see directly, I guess, so, okay, these are the hiring ones, and maybe the short title ones are all in this one cluster. So I think it's more about getting a sense of general topography of a map, like looking at Google Maps at a very high settings, and then when you really want to zoom in on the details, you crank up the number of clusters, and that would give you some very specific areas, but you'd lose a little bit of the high level. So you get very specific machine learning, let's say, and deep learning clusters here, and that are not just about technology, so to speak. So this is interesting, just completely by chance, and the model clusters it or labels it correctly. That's a great question. Thank you, Jeremy.
Awesome. Thank you, Jeremy. Do we have more questions? I'll use the opportunity to follow up on, I think, I'm not sure you mentioned it during this presentation, but I think in your article you mentioned other potential use cases to build something with the embed. And so I was wondering whether you have been thinking of any specific types of applications, products, use cases that could be that could grow out of this.
So embeddings are very they're general problem-solving tools for retrieval and search. They have immense capabilities. Now, this specific sort of demo or work, I think, extends very easily to other data sets. One thing that we kind of explored with Pinecone in the webinar is to say, let's get the best or top questions from the Ask Science subreddit. And so we got the top questions and their answers as well. And so that is a data set that is ready to be sort of visualized and explored kind of like this. But it's also one where we don't just have the questions or the title, we have the question and the top voted answers for each one. So that one is sort of it can serve as, you know, to demonstrate interesting questions, but also gives you their answers. There are a lot of subreddits that are interesting to explore kind of like this. So in addition to Ask Science, at the top of my head are things like Ask Historians. These are very highly curated Reddits with super insightful discussions and sort of people who put a lot of information into these discussions. So this is just, to me, is a tool to explore large archives of text by meaning, and I think it's. But the retrieval side to me is very important. So I wrote about embedding using retrieval in generative models to, you know, give them more information. One of my favorite exercises here is the co-search channel here in the Discord as well, that does something kind of like this, that uses Google as a retrieval. So that area of using embeddings is another one that is extremely exciting to me.
Oh yeah, this is cool, guys. If you haven't yet poked CoSearch, you can find it in under the tab Project Showcase. Go and have fun with our bot. It gets pretty hilarious at times, so I highly recommend you to test it out. Awesome. I guess if we don't have any more questions, we can wrap up here, unless somebody wants to chime in. Final chance. J Alammar live. Alrighty then. So Jay, once again, a huge thank you for spending this session time with us. Yeah, guys, thank you so much for showing up. Hope this was interesting. Let us know how you like it. And as I mentioned, if you have anything to share, I'd love to hear from you, and see you on the next session on Friday.
Perfect. Thank you, Sandra. Thank you, everybody, for coming. If you have any questions, feel free to post them in any of the channels here. I'll be happy to continue talking about this. Have a great day.